Hi friends, in this video we'll learn differences between ArrayList and LinkedList. So in this video I'll cover all the differences between these two data structures. Please watch this video till the end because this is an important question in Java interviews for both freshers and experienced as well. So before learning the differences between these two data structures, let us know how data is internally stored in an array and a linked list, because ArrayList and LinkedList are having arrays and linked list, double linked list as the underlying data structures. So let's get started. For example, if we take an array, so let us assume this is a heap memory, and let us assume we have an integer array of size 7. Okay, new array of 7. So at runtime, while creation of the array, the memory is allocated in the heap, and the memory for array will be contiguous memory. So it will be given a continuous memory cells for an array. So if we have created an array of size 7, so this will be index 0, this will be 1, 2, 3, 4, 5, 6. Okay, so the array size is 7. Now whenever we are inserting some element into the array, so let us assume we are inserting 5 here, and we have 24, 27 and so on, the insertion happens contiguously. So the memory allocation for array is contiguous. Whereas if we take a linked list, so linked list we are taking a single linked list. Let us take single linked list. Each node is allocated memory not contiguously, randomly it will be given in the heap. So one node will be stored at some memory location, and the second node can be stored somewhere else, and third node can be stored somewhere else, right? The memory allocation is not contiguous in linked list. So the first node points to second node points to third node. This is the memory allocation for linked list. So now let us see how the insertion happens in an array. Suppose if we have introduced 5, 4, 27 and 8, 9, 3, 2. These are the elements inserted. Now I wanted to remove 27. So both arrays and linked list can be directly accessed through index, right? They have the indexes. Now in an array I want to remove 27. I go to the index 2, remove it. So there will be a space formed here, right? But in an array, memory will be contiguous. There won't be any spaces. So the rearrangement happens here. Whenever you remove 27, all the previous elements will be adjusted by one space, right? So all this movement happens in an array. Whereas in a linked list, if you want to delete this second this one, let us this 1, 2, 0, 1, 2. I want to remove this element. If suppose this is 5, 24, 27, I want to remove this. Now there need not be any rearrangement, because what we do is we can the pointer from this first node is pointing second, and second node points to third. Now we will directly point first node to the third node, and we remove this and this. That's it. We are just deleting the linkages, so no movement of the memory will happen in linked list. Here in Java collections framework we have ArrayList. We are discussing ArrayList and LinkedList. You notice here we have an interface called DQ, and LinkedList is implementing DQ, whereas ArrayList is not implementing DQ, it is only implementing list. Now from this we can understand that LinkedList can behave both as a list and a queue as well. I will tell you the reason. Now this is one point to note. Now both ArrayList and LinkedList, they are index based, and this one is also index based, and order is preserved, insertion order is preserved, and same here, order is preserved. When you are inserting some element, by default they get added to the end. So the order of insertion is preserved in both ArrayList and LinkedList. Now array list is based on the underlying data structure for array list is dynamic array. Okay, dynamically resizable array, and the underlying data structure for linked list is doubly linked list. One more difference is array list implements random access interface, whereas linked list don't implement random access interface. Random access interface is a marker interface to tell that this particular data structure is having very quick access through index. Now both linked list and array list are having access through index, but then why array list is implementing random access and why not linked list? There is a reason for that. I will explain you. Now similarly, one more difference is array list don't implement DQ, whereas linked list implements DQ interface. Now because of this, linked list will get the behavior of queue as well. What is the behavior of queue? Whenever you have some queue, we can insert or delete from both ends as well. So there are separate methods in the DQ interface. I will show you those methods, but there is a reason for not making array list implement DQ interface. That as well we will cover. Now let us try to understand why array list is implementing random access interface and why linked list is not implementing random access interface. As I said, random access interface is a marker interface which conveys to the developers that whichever data structure is implementing random access interface will have very fast retrievals on index. Right? Random access means there will be randomly we can access any element in that particular data structure at a very good speed. So here both array list and linked list we can get elements based on the index, but then this marker interface says that array list will fetch you faster, retrieval will be very fast on index, whereas linked list is not implementing random marker interface, random access interface, telling us that it is not very fast in retrieving elements in linked list through index. Now the reason is, suppose whenever you want to access an element in an array list on index, we can directly go to that index because elements are contiguously stored. So we know this memory, okay, initial element memory plus 4 bytes. It is, since this is an int array, we will have 4 bytes allocated for each memory. So it will calculate when we are trying to access this index 4, it will calculate the address at this location plus how for each element it adds 4, and then it will directly go to this location. Whereas in linked list, since the memory is not contiguous and they are stored randomly but are linked through pointers, every time the travel or transition should start with the starting element. So if you are trying to access some nth element, it has to travel all through these nodes, so making your transition or fetching using indexes slower in linked list. And that's why, to indicate that array list is having very fast retrieval on index, array list is implementing random access interface. And similarly DQ. Now let us understand why array list is not implementing DQ interface, whereas linked list is implementing DQ interface. DQ is nothing but doubly ended queue. So if you have a queue here, doubly ended queue means we can either add or remove at both the ends. Okay, we can do some updations at both the ends, either adding or removing or updating. Now in an array list, if we are adding something at the beginning, array list is using dynamically resizable array, right? So if you are adding something at the beginning, there will be a lot of restructuring happens, right? Whenever you are adding something at the beginning, all the following elements will shift by one position to the right. Similarly, if you're removing something from the beginning, all the elements to the right side shift one position to the left, like this. Always lot of reshuffling happens, right? Whereas in a linked list, directly do some updates in the beginning or end without disturbing any nodes in between, right? That's because we are only changing the linkages. In linked list, the nodes are not stored contiguously, they are stored randomly, and each node is linked through the pointers. So we don't change any memory allocations for the remaining nodes. And that's why that is a basic principle of a DQ. In a DQ, we can do operations like updations or deletions at the end of the data structure, at the end nodes, like starting or ending nodes, right? That behavior we want, that behavior is also possible in linked list. That's why linked list is implementing DQ interface. Now let us learn time complexities for insertion, removal and retrieval in both ArrayList and LinkedList. So let us take ArrayList and LinkedList. We have operations like insert. So the insert can happen at the beginning or at the middle or at the end. Now ArrayList, the data structure, underlying data structure is dynamically resizable array. So what is dynamically resizable array means? If you take an array having 0, 1, 2, 3, 4, 5, 6, these are the indexes, and let us assume we have elements like 3, 2, 24, 27, 9, 6, 7. These are the elements. Now if this array is not dynamically resizable, what happens is, if you are inserting some element at position 3, so it will just replace with the new element. So since that means the size will be fixed. So whenever you are declaring a primitive arrays like this, here this is a fixed array, fixed size array. So whenever you are having a fixed size arrays, if you are inserting some position at some if you are inserting some element at some position, it will replace the old one. Whereas if the array is dynamic, so let us copy the same one. So if the array is dynamic, what happens is, I'm trying to insert some element at position 4, let it be 43. Now what happens is, in a dynamic array, we will create a new space at 4 and shift all the elements to the right of that new element by one place. So what happens is, we'll create a new array. And we are inserting 43 here. So 5th index will now have 9, 6th index will now have 6, 7th index will have 7. So we have created space for one new element. But while inserting in somewhere in middle, what happened is, we are shifting all the elements to the right side by one place. So there is lot of reshuffling happening, right? So this is called dynamic array, and ArrayList uses this dynamic array internally. Okay, so also in an ArrayList, by default there will be 10 elements. Whenever we are inserting something in an array, it will always check for the size, and once it reaches the 10, it will double the size and all the reshuffling happens again. So it will copy all the elements to the new array, and the old array will be garbage collected. So if you are inserting in between, what happens is, there will be some movements to the remaining elements. So the complexity will be big of n. If there are many elements here, if there are some n elements, there will be many shufflings, right? So the worst case scenario can be big of n. Similarly, if you are inserting something at the beginning, so all the elements to the right of that element of that index will move to the right by one position. So even at the beginning, big O of n. That is the worst time complexity. Now if you are inserting at the end in an array list, if you are inserting at the end, now there are two cases. If the array list, as I told you, the initial size will be 10 elements, and if still there is a place, suppose if this is the array list we have, and we are trying to insert at the end, okay, that's end position. So if there are no elements, if there are some spaces available, it will directly insert. But then if you are trying to insert here in this dynamic array where the last element, where the array is full, then there will be again reshuffling happens. So it will copy all these elements to, it will create a new array list with the size doubled, and then we'll have we will copy all these elements, and then we'll insert the new element at the end. So again here at the end the worst case complexity will be big of n. Okay, so this is about array list. Now coming to linked list, when we are inserting at the beginning, in the middle, at the end. For a linked list, the underlying data structure is doubly linked list. Now let us try to understand the insertion time complexity for insertion in a linked list. So the linked list from Java collections, it internally uses doubly linked list. Okay, so let us take the nodes in a doubly linked list. Every node will have pointers to two pointers, one pointing to the previous node, another pointing to the next node. And also doubly linked list will not be stored consecutively, right? Contiguous memory won't be allocated. The nodes can be allocated randomly, but pointers will be linked. So let us assume our linked list is something like this, stored something like this. Okay, now let this be first node, second node, third, fourth, and this is the last node. Now if we are trying to insert in the beginning, it will be big of 1, because we will have the pointer to this, we will have already the reference to the first node, so this will be big of 1. Now inserting here, simply what happens is it creates a new node here, and this next pointer will be pointed to this, so this will be our new node. Okay, just there is a change in pointers, but if you notice there is no change in other elements, there is no change in shuffling, there is no reshuffling, nothing is there, right? So this is big of 1. Now if you are inserting somewhere in between, okay, somewhere in between, let us take here, we are trying to insert a new node here. What we do in a linked list, we always have a handle to the first node itself. So we will start from here, we go to the second node, we go to third node, we go to the fourth node, and we allocate a new space for our new node, and then we change the pointers. We change the pointer here, we put to this here, and we delete the old pointer. So what happened here is there is no reshuffling happened, right? All other elements are not touched. Only we created a space for new element, and then linkages happen. But we can't say this as big of 1. This operation is not big of 1 because we are traversing. To reach this position, we should always traverse from the beginning, and we reach here. So here it will be big of n. Similarly, to insert some node at the end here, we need to traverse starting from first node, we traverse all the way to the last node, and we do the linkages. So this will be our new node now, right? The inserting at the end. So even this is big of n, but there is lot of difference. Though the time complexities looks similar in ArrayList and LinkedList, for insert, LinkedList is much faster, because here in an ArrayList there are lot of reshuffling happens. Reshuffling takes place, right? But here we don't have reshuffling, but we only have traversal. So the time complexity, the performance is very good in linked list during insertions or removals. Even it is same in case of removal also. So insertion or removal, both. Okay, let us take this array list. We are trying to remove an element from the beginning, so we remove this. What happens is reshuffling happens again. We remove this data, so all the previous nodes will shift to left by one position. Okay, this happens in an array list. Now, so insertion, removal, we are done. Now let us learn retrieval. So if you are trying to retrieve something from the beginning will be big of 1. So if the element is the first element, that is big of 1 in an array list. And if you are trying to search from between, I mean from any index, we can directly retrieve using big of 1. Similarly, from the end, if the element is at the end, we are retrieving from the last element, still it will be big of 1 because we access through index. Now let us learn about time complexity for retrievals in linked list. So again, beginning, middle, end. So here also retrieval can happen on a linked list on index base. So if the index is the first index, that will be big of 1. If the index is somewhere in the middle, we always traverse, right? So big of 1 is wrong. What happens is the time complexity will be big of n, because to reach some middle position also we need to traverse from the beginning, right? So somewhere not exactly middle in the sense not exactly middle, it can be anywhere in between. That's what I meant by middle. Okay, at the end, last position. So if you're trying to get element from the last position, even then the time complexity will be big of n, because we need to travel all the way from the first node. So retrieval is very late in linked list. Insertions or removals are very fast in linked list. Okay, don't confuse with the time complexity. The time complexity may look same, but then the performance varies a lot, because in array list lot of reshuffling happens. In a linked list no reshuffling happens, only traversal happens and the creation of one single node without touching other nodes. This is all about insertion, deletion, retrieval time complexities for linked list and array list. Now coming to memory. Array list requires less memory, whereas linked list requires a bit more memory, because we maintain 2 pointers. With each node we maintain 2 pointers, so that requires memory. Now coming to when to use, we use array list when the application is more read intensive applications. When we have lot of retrievals happening in our application, we go for array list because retrievals are pretty fast in array list. Whereas when we have write intensive applications, we go for linked list, because in linked list insertion, deletions, updates are pretty fast compared to array list, right? So these are the main differences between array list and linked list. Let's go to the code and let me show you the internal implementations of both these data structures. I have written a small program. Let us see. We have declared a primitive array. I have given some inserted some values here. Now I'm printing this array, and now what I'm trying to do is I'm trying to put element 10 in index 7, and this is a fixed size array. This is not a dynamically resizable array, this is a fixed size array. So what happens is when we insert 10 at index 7, we should see new element replacing the old element. So let's see that. You see this? We have 1 2 3 4 5 6 7 8 9 10. We have 1 2 3 4 5 6 7. 8 is replaced by 10. The 7th index is replaced by 10, since this is a fixed array. And here there is something to note. You see this, when I am printing the array, it prints the reference, this one. What is this? The class name and then at the rate the address. So what is this? Let me explain you something about this. Here if you notice this, we are actually printing the reference, right? We have the array here. Okay, this is in the stack, and we have a heap memory, and inside the heap we have actual array, right? And this reference variable is pointing to this is the address. We have some address. So this array will have the address. So when we are trying to print that array address, it's printing the class name, and then it prints the class name @address. So here if you take this one, we have something like this. We have some address part. So what is this one? What is this? This is nothing but the class name of primitive arrays. So everything in Java will have a class. So even our primitive arrays will have class names, but this class is not accessible. Okay, this is given internally. So similarly, if we have an array of type double array, okay, if we have something of double array, this class name will be given as D internally. Suppose if we have something like int array, which is a two-dimensional array, so the class name for this will be, we will have something like this. This is the class name given internally. So we are done discussing this point. I just wanted to discuss this point as well. Now let us see what happens with the insertions in linked list. In linked list, we are not using static array or fixed size array. We are using dynamically resizable array. So which means it won't replace the existing object. Instead it will create a space for the new object, new value, and it will extend and it will shift the other values. That's what we discussed earlier, right? So let us see that in example. Let me uncomment this. So I will comment this code. Here we have taken an array list. This is an array list, and our array list is having 3 elements, 10, 20, 30, and we are inserting 40 in the second position, in the second index. If the array is fixed index, fixed size array, then it will replace 30 with 40, but then here it won't replace. Now you see this, the previous elements are 10, 20, 30, and after insertion it became 10, 20, 40, 30. So what happened is it resized. So if you go to array list, here the default capacity, you can see the default capacity will be 10, somewhere it will be here. Default capacity is 10, and then let us see this. Get off index. So when we are trying to get off index, it will check index, and then it will directly get the element at that particular index. Okay, whereas in linked list, let me show that linked list. Whereas in linked list, when we say get off index, it traverses. So is element between this and this, and then check element index, and then node of this one. You see this, the traversal is happening, right? So it traverses and then gives the value. So get, and also you see here in the linked list, we don't have any implementation. We didn't implement random access interface, but in an array list you can see that we have implemented random access interface, right? Also in linked list we have some method, we are implementing DQ, right? DQ. So we are giving behavior of a queue to linked list. So what are the methods we have here in DQ? We have peak, poll, see here, peak first, peak last, poll, peak first. So all these methods will be available to linked list as well. So all these methods, or this DQ is nothing but the behavior of a queue. So that we are giving it to linked list. So now your linked list can behave both as a linked list as well as a queue. So these are the differences we have. Now let me reiterate once again all the points. Array list and linked list both are index based, and both are order is preserved. Whatever order we are inserting, not in between, whatever order we are inserting, the order is preserved. And ArrayList backend data structure is resizable dynamic array. Linked list, it is doubly linked list. ArrayList implements a random access interface, which is a marker interface. The reason being, in ArrayList the elements are stored consecutively, so contiguous memory is given, so that's why we can easily access. Random access is very much fast. Okay, we need not traverse from the first node all the time. Whereas in linked list, random access is pretty slow. Random access is still there via index, but it is very slow compared to array list. That's why linked list is not implementing that marker interface, because marker interface don't add any functionality, but then it is just for giving information. So random access interface implementation on array list says that your random access in array list is very fast, and the underlying reason for that is elements are stored consecutively in an array, whereas elements are not stored consecutively in a linked list. That's why retrieval on index always happens from the start of the index, starting element, and it will traverse and get the element for us. Similarly, for an array list we don't have queue functionality, whereas linked list we have given queue functionality, because linked list is having doubly linked list internally, and doubly linked list, whenever we are inserting at the beginning or at the end, we need not traverse all the way. Only for insertion at the end we need to traverse from the beginning, but insertion at the beginning it will be big of 1. Now coming to insertions and removals and retrievals, this is the time complexity. So finally, memory wise, array list takes less place and linked list take more space. And when to use, array lists are used in read intensive applications, linked lists are used in write intensive applications. I hope this video is helpful. If you like the content, please like and share this video. Thank you.